Hello everyone, in this video we will talk about plotting in Matlab. In this video we will cover only 2D plotting, but Matlab provides 3D plotting options too. To start plotting something, we need to create an empty figure with figure command. The figure command will create an empty figure for us, and I will dock it into my Matlab window. Right now, I will see the difference when I write a command in the figure. Okay. To plot something, first we need to create our data. Let's write a is equal to from 1 to 9. That's good. And let's create the data for the y-axis. Let's say y is equal to x scalar square x scalar square. You will see that y is the square of x, scalar square of x. Let's plot them. To plot something, you need to use the plot function. And in that plot function, first you need to give the data for x-axis, which is x right now, and second you need to give the data for y-axis. Right now it's y. As you can see, my plot function draws something in my figure, and the x-axis starts from 1 to 9 and y-axis starts from 0 to 90. And let's add some label. Let's add a label for x-axis. Okay, let's say x label. You can use x label function, and this is a label for x-axis. Right now there is a label in my x-axis. As the same way, you can use the same function with y, which is y label, and you can say this is a label for y-axis, and this is good. And let's add a label for my figure, but this time let it be a title. To add a title, we can use a title function, and in that title function you can use your title. You can write your title. Let's say best title ever, but this time I want to add some attributes for that label. I want to change its font size. If you change some attribute of your label or of your plot or anything, you need to add them as a parameters. Right now I add a font size, and I need to give the value in another parameter. Right now 25. As you can see in my figure, I have a best title ever title, but this time its font size is 25. You can do this same thing for the X label and Y label. You can change your labels font size, font weight, font name, and font angles by using the parameters. The font weight specifies your text is bold or normal. The angle specifies your text is italic or normal. The font name is the font name. Okay, and we have line specifications for plot function. What are they? Let's look in here. The slideshow, play from current slide. Yes. And we have some line styles. And we have a keyword for some specific lines. For example, for a solid line, we can use dash. For a dashed line, we can use double dash. And the results in the right column. If you use a colon for a line style, it will be the dot line. And if you use dash and dot together, your line will be dash dot dash dot. And we have also marker styles. The previous plot function doesn't add any marker in our line. It just adds a straight line, a solid line. But we can add some markers in our plot function. And there is some keywords for some markers. As you can see, we will use some of them, but you can see the results in the right column. We have circle, plus sign, asterisk, point, cross, horizontal line, vertical line, square, diamond, etc. And finally, for line specification, we have some colors, predefined colors. And you can see the color names and their short names, their keywords. For example, R means red, G means green, B means blue, C means cyan, M means magenta, and Y means yellow, K means black, and W means white. And let's try them into Matlab. If you remember, we already plot some line in here, but this time I want to change that line with some line specification. I will use the same plot function and same x and same y, but this time I will add some line specification. I will say that let's make that line red and let's make that line dashed line. If you click enter, you will see that our line becomes red and dashed line. And if you want to use a marker for your line, for your data, and you can use a marker keyword in here. Let's say O. O will create some cycles for my data. As you can see in here, I have some circles, but they are a little bit small. Let's increase their sizes. We can use some specification names, some attribute names to change in plot function. Let's say we want to change the marker size. Then I will write here a marker size. Let's say 5. It doesn't change, but if you write here 25, you will see the change. Our markers are right now 25. And if you want to change, for example, another attribute, let's say the line width, we can use the same thing in here, or let's edit, and after a comma I need to write and line width, let's say 3. Right now you will see that my line get thicker. And we have lots of attributes, and you can look for them at your own. In this course, I will show some of them. And let's show another attribute, which is color. Oops, I will delete everything right now. Right now, I don't want to use the line specification like that. This time I will give a color with RGB values. For example, 1, 0, 0. If I click enter, you will see that it will create a color. It will create a line, but this time its color comes from RGB values. If you change that RGB value like that, your color of line will change. And if you don't want to draw a line, you can use the line specification again, but this time you can delete the line style. This time you will get the data points with some markers without a line. And if you don't want to draw all markers for each element of X, you can specify that which indices will be used to create a marker. Let's say marker indices, and I want to create marker for first, second, fifth, and eighth indices. And this time you will see that the first, second, fifth, and eighth indices I have a marker, and the rest of them I don't have a marker. And this is the plotting. We can specify our axis too. For example, right now I cannot read the variables on my axis. Why? Because they are too small. Let's change the font size of my axis. To change the font size of my axis, we can use GCA keyword. Let's say AX equal to GCA. GCA means get current axis. In that axis, you will see that some properties: X lim, Y lim, X scale, Y scale, something else. And if you click the all properties, you will see that all properties about that axis. And if you want to change anything in that axis, you need to use a dot, like a subtract. Okay, AX dot font size equals 25. Right now, as you can see, I have changed everything. I changed the font size of everything. And let's clear our window and let's continue to change something. And let's limit our axis. Let's limit the axis X with X lim function. Let's say I want to see my X axis between 2 and 8, not from 0 to 10. Right now, as you can see, I changed the limitation of my axis. I have 2 to 8, and the first marker is lost right now. And at the same way, we can use the y_lim function to limit the axis y. Let's use this time from 20 to 50. Right now, I have an axis y which is starting from 20 to 50. And you can use axis method to limit your axis together. Let's say I want x-axis from 1 to 7 and my y-axis from 10 to 70. Right now I have x-axis from 1 to 7, I have y-axis from 10 to 70. And as you can see, I have an axis function for x and for y. After this point, I will use only the functions for x, but it doesn't mean that we have the functions only for x. We have functions for y too. Let's look at x ticks, which is here. Right now I have 2, 4 and 6. I want to change that x ticks. I want the ticks at 1, 2, 3, 5, 7 and 9. As you can see, right now I have x ticks like I gave it. And I can change the format of the ticks. Right now I have 1, 2, 3, 4, 5, 1, 2, 3, 5 and 7, and I want to change their format with xFormat function. This time I will write %d and the number will be replaced with that %d like a string formatting, and I want to add a kilometer after my number. Oops. Oh, sorry, I didn't add xtick format. My function should be xtick format, and this time you will see that my labels for ticks is 1 kilometer, 2 kilometer, 3 kilometer, 5 kilometer and 7 kilometer. And we can change their angle, their direction with xtick angle function. And we need to give a degree, not a radian. We need to give a degree here. If you write here a 45 and your xtick labels angle will be 45, and if we give there a 90, the angle will be 90 degree for my xtick labels. And if you want to specify your xtick labels, you can use xtick labels function too instead of xtick format. And this time you need to give a string array or a cell array. But I will use a string. I have 5 tick and I need to give 5 string. I want to say first one A, B, C, def, something. For example, I have right now a 5 string. If I click enter, you will see that my xtick labels will change. I have right now A, B, C, def, and something. And you can change everything in your axis. And to reach your axis, you need to use GCM keyword, like I said before. And in AX, which is the variable for my axes, you can see I have lots of parameters, lots of properties. And as you can see in here, I have a Y scale. Right now, I will plot my figure again, like that. But this time I want to scale my y-axis logarithmic. And to change it, I can use ax dot y scale equals to log. As you can see, the scale of my axis y becomes logarithmic. And we can change these attributes with a set method. Before to go to set method, I want to show you a get method. For example, I want to get the xtick labels, and let's say get from current axis, and I want to get the property which named xtick label. If I write here, I will get a cell array which are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Why? Because these are my xtick labels right now. If you want to change something in that xtick label, you can use set function too. Let's say I want to change something, I want to set something to current axis and the xtick label property. This time you need to give some variable for xtick label. Let's say, for example, this time I want to show 1, 4 and 9. But this is label, I need to give a string for them. But I need to give lots of string. I need to give 9 string because I have right now here a 9 tick. And then let's delete here. I don't want to change the xtick label. Then I need to get from current axis xtick labels. Right now I have A, which is cell array, and if I want to set my xtick label again, right now I can say I don't want to change the labels. Then I can give the previous labels, which is right now A. But this time I want to change the font size of the X label, X-tick labels. Right now I can write here font size, which is 25. And right now, as you can see, the label is changed. The font size is changed to 25. Okay, let's clear everything and let's clear our figure 2. Let's define some data again. X equal 1 to 9 and y equals to x square, x color square. And I want to plot x and y with red line and dash with O, and I want to add line with attribute, which is 3. Right now I have, and as you can see, I have some markers in here, and let's increase the marker size. Yes, it's more visible right now. And if I write a grid on command, my chart will be more readable. Right now I can see which marker in which level. You can use grid of command to remove the grids. And if you want to plot one more line in your figure, you need to use hold command. You need to use hold on command. And after that, if you write another plot command, it will add another line instead of deleting the first one. Let's look at, and let's create a y2 equals x scalar over 3, and let's plot it. I will use the same plot, but this time I don't want to use a circle. I want to use the asterisk for marker, and I don't want the dashed line. I want to use the solid line, and I want to use the color blue, but this time I will use the Y tool for the data for Y axis. And as you can see, I have 2 lines in my figure thanks to hold on command. Right now I have 2 lines, but I don't know which line represent what. So I need to add some legend in here. Let's add legend. The first legend, my first line, which was x square, if you remember, and I will write here x square. And the second one is x over 3. Right now here I have a legend. The red one, which says the red one is x square and the blue one is x over 3. And if you notice that I wrote here a hat, but I don't see a hat here because Matlab used the latex string formation. which is nice. And we can change the font size of our legend as the same way. Let's say 18. Right now it's increased, but I don't want to see my legend in here. I want to change its location, so I can use another attribute which named location, and you can use directions. For example, north, it will be placed in north, and if you use northwest, it will be placed to northwest. And if you use best instead of the directions, it will find the emptiest position for your legend. And I want to remove the rectangle of my legend. I want to remove that box, so I need to use legend box off. And if you use legend box on, it will draw the rectangle again. It will draw the box again. Okay, what if I want to draw multiple plots in any figure? Then I need to divide my figure into the parts like a matrix. Let's clear the command window. Let's remember X, Y, and Y2. And I want to create right now a figure which is empty figure, and I want to dock it again, and I will plot the same function, same line again, but this time I want to use a subplot. The subplot will divide your figure into the parts, and I want to divide my figure in 2 rows and 1 column, and I want to draw the first one. As you can see, my figure is divided into 2 parts, which is 2 by 1, 2 row and 1 column. If you use 2 row, 2 column, and I want to draw the first one, this time your figure is divided into 4 parts, which is 2 by 2, and right now I'm plotting the first one. And if you want to plot the second one, it will be right here. And if you want to add another plot, but this time I want to use the whole part of my figure, rest of my figure, and I need to divide my figure again, but this time I need to use 2 row again. Okay, the first row has 2 plots, and I don't want to use multiple column for my second row. Then I will use 2 by 1, and I will use the second part of my 2 by 1 parts. Right now, as you can see, it divided my figure 2 by 1, and it drew the plot. It plotted into the second part. And if I write here plot something x and y, it will be plotted to here. Why? Because right now I'm here. I'm in 2 by 1 and the second part of 2 by 1 figure. If I want to draw the first one again, which is the first one of 2 by 2 figure, then I need to use the subplot 2 by 2 and the first one, and I can use another plot here, which is x and y2. And for the second one, and I can use something else. You can use any function which I showed before in here. For each subplot you can use everything. Let's say x and y again. Let's add some red, dash and O. I have 3 subplots in a figure. Why? Because I have divided into multiple parts of my figure. So, and this is the plot. The plot helps you to draw some lines and some markers. In Matlab, we have some other functions to plot some charts. Let's clear our window. Let's create another figure here, and I will dock it again. Right now I have a new empty figure, and I want to use a histogram right now. Let's create a data which is totally random. Let's say data is equals rand, let's say 100. It will create 100, 1 by 100. It will create a row vector, as you see, 1 by 100. Let's clear our window again. I want to draw a histogram of that data. If you use histogram function with your data, it will draw something in here. As you can see, I have an histogram. I have used a rand function to create these data, and the data should be uniformly distributed. If I use this time 1000 value, but this time I will prevent echo, and if I use my date histogram function again, this time I will get more uniformly distribution. Why? I used more data than 100. And if you can see in here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins here. And if you want more bins, for example, let's say I want 20 bin, you can use another parameter, which is the bin count. It's 20. And let's create more data, which is 10,000, and let's create data. And as you see, as I increase the data count, my distribution becomes uniform. And let's create a normal distributed data, and this time I will use rand n, which produced the negative and the positive variables with normal distribution, with Gaussian distribution, but the mean will be 0. And if I use the histogram again, you will see that the normal distribution in that histogram, because I created my data with random normal distribution function, which is rand n. This is how to draw a histogram in Matlab. Okay, let's clear here and let's draw a pie chart. And to draw a pie chart, we need to use the pie function, but first we need to give a data in here. Let's say data equals to 10, 50, 30, 20, 40. I think it's enough. And to draw a pie chart, you can use a pie function with data. And as you can see, Matlab produces a pie chart for you. And you will see the numbers in here. As you can see, I have written a data in here, but this data is not the percentage of the data. Matlab calculates the percentage of each element and then it writes into the pie chart. And this is the end of our course and end of our video. Thanks for watching me. Bye.